Good morning, everyone. I would like to welcome you to Immunic's webcast to present the positive results from our single and multiple ascending dose parts of the phase 1 clinical trial of IMU-856 in healthy human subjects. My name is Jessica Brew, Head of Investor Relations and Communications at Immunic. I will also be the moderator on today's webcast. Speaking on the call are our Chief Executive Officer and President, Dr. Daniel Vitt, and our Chief Medical Officer, Dr. Andreas Müller. Please note, all participants will be in listen-only mode, and this event is being recorded. After today's presentation, there will be an opportunity to ask questions. If you joined the webcast via the Zoom platform, there are two ways to submit questions. You can either submit your questions in writing via the Q&A tool of the Zoom portal, or if you would like to speak with us directly, please use the raise hand function in the Zoom portal to queue your question. Before we begin, I would like to remind you that this presentation may contain forward-looking statements. Such statements can be identified by words such as may, will, expect, anticipate, estimate, or words with a similar meaning. And such statements involve a number of risks and uncertainties that could cause Immunic's actual results to differ materially from those discussed here. Please note that these forward-looking statements reflect Immunic's opinions only as of the date of this presentation, and it undertakes no obligation to revise or publicly release the result of any revision to these forward-looking statements in light of new information or future events. Please refer to Immunic's SEC filings for a more detailed description of the risk factors that may affect Immunic's results and these forward-looking statements. I would now like to turn the webcast over to our CEO and President, Dr. Daniel Vitt, to begin the presentation. Please go ahead.
Yeah, thank you, Jessica, for the kind introduction, and a warm welcome from my end to today's call. At Immunic, we have 3 products in clinical development, including our ENSURE program, a registration trial for vidofludimus calcium in multiple sclerosis, supported by a phase 2 in progressive MS, the Celiac trial. Our second program, called IMU-935, is an oral IL-17 inhibitor, and to our knowledge, the first Th17 selective ROR gamma T inverse agonist in clinical testing. But today, I'm happy to share first results from the first in-human trial of our third program, IMU-856. This program is targeting the restoration of the proper barrier function in the human gut wall. IMU-856 is targeting the barrier function by interacting with a new yet undisclosed protein. I hope you understand that we keep this as a secret in order to protect the asset from too early competition. And now I would like to hand over to our Chief Medical Officer, Andreas Müller, to share more details how nicely IMU-856 behaves in humans. Andreas.
Thanks, Daniel, and good morning, everybody. I would like to report today to you the unblinded phase 1 results of our third drug development candidate, IMU-856, from both the ascending single and multiple dose evaluations in healthy human subjects. At the end, I will also give an outlook on the ongoing phase 1b portion of this trial in celiac disease patients. Please note that we are at this webcast to present only the main results of the phase 1 trial in healthy human subjects. However, we have included extended information sections in the filed documents that contain much more detailed information and which you can access at any time. Let's start with the general design and the way we performed dose escalation in this phase 1 trial performed in Australia. The phase 1 trial of IMU-856 consisted of 3 general parts. Part A was a dose escalation for single doses of IMU-856, and a total of 45 healthy human subjects were exposed to placebo or doses between 10 and 160 milligrams of IMU-856. Part B was a dose escalation for multiple daily doses of IMU-856 over 14 days, and a total of 26 human subjects were exposed to placebo or doses between 40 and 160 milligrams of IMU-856. Part C is the ongoing evaluation of 2 doses of IMU-856, 80 and 160 milligrams of IMU-856 in patients with well-controlled celiac disease. A total of approximately 42 celiac disease patients are planned to be included. This part is actively recruiting in Australia and New Zealand at this time. This slide summarizes how the dose escalation in part A was done in a way that consecutively higher doses were allowed after an evaluation by an independent safety management group. In addition, sentinel patients were used in each dose group before the remainder of the dose was dosed. All dosing in this phase 1 trial for all parts was done as oral tablet administration. This slide summarizes the pharmacokinetic results from part A single doses. Most noteworthy are that we see a rapid absorption after oral tablet administration with peak plasma concentrations reached within 2 to 4 hours. The terminal plasma half-life of IMU-856 is 16 to 20 hours, which is well suited for once daily dosing. And we observed a dose proportional increase in plasma Cmax and AUC with increasing doses. Again, there are more detailed data in the filed documents. However, this slide summarizes what we have observed in part A for single doses of IMU-856. There were no serious adverse events, and there was no trend for dose-dependent adverse events. There was no maximum tolerated dose that we reached, and the study used a dosing to efficacy approach where we were able to reach the planned highest dose of 160 milligram IMU-856. And there were no drug-related adverse events regarding lab parameters or any medically relevant changes in ECG or vital signs. In conclusion, single ascending oral doses of IMU-856 provided a favorable safety and tolerability profile, which also allowed a smooth transition from part A, the SAD part, to part B, the MAD part, in healthy human subjects. In part B, daily oral administration of 40, 80, and 160 milligrams IMU-856 was investigated over 14 days in healthy human subjects. Similar to part A, certain algorithms, including the use of sentinel participants, were used to safeguard the risk to study participants. Part B was able to complete the study with the intended highest dose of 160 milligram IMU-856. This slide summarizes the pharmacokinetic results of the 3 doses of IMU-856 used in part B, both at day 1 and at day 14 of dosing. Most noteworthy are that, similar to part A, terminal plasma half-life at steady state at day 14 was 17 to 21 hours. Linear pharmacokinetics were also confirmed after multiple dosing with dose proportional increase in plasma Cmax and AUC over increasing doses. And an accumulation factor of about 1.5 was found between day 1 and day 14, which should result in predictable trough levels and drug exposure after once daily oral administration. When we look at the plasma trough levels of IMU-856 over the study period, we can acknowledge a rapid achievement of stable, steady state levels already after 4 to 7 days of dosing. Following the end of dosing at day 14, there's a fast drop-off in plasma concentration according to the terminal plasma half-life of this drug. By the way, the dotted lines at the bottom of this graph represent the EC50 and EC90 concentration from an ex vivo inhibition of an enzymatic function in a cellular test system, representing target inhibition. This confirms that the IMU-856 trough levels that we have seen in this phase 1 are well above what we consider potentially active dose levels. The next slide addresses the safety and tolerability profile of IMU-856 observed in this phase 1 trial. Once daily 14-day dosing of IMU-856 was found to be safe and well tolerated. This first slide shows that the number and nature of adverse events were similar between IMU-856 and placebo. Please remember that there was a 3-to-1 randomization used in this trial. In addition, there was no dose dependency in adverse events, and there were no drug-related serious adverse events. When we dig a little bit deeper, we find that the observed most common adverse events in this trial were catheter site pain and headache. looking at drug-related adverse events, diarrhea and abdominal pain are the most common drug-related and treatment-emergent adverse events, but both were exclusively mild in severity. This slide, in an exemplary fashion, displays the hematological lab variable of neutrophils in blood. The left side of this slide shows that there's no trend of the number of neutrophils for post-dose changes over time, and the number of neutrophils in blood remains unchanged and stable. The right side of the slide shows the shifts in the number of neutrophils on several post-dose time points versus baseline. This also visually confirms that there's no systematic change of number of neutrophils at these time points. Please remember that IMU-856's target is not primarily related to the immune system, and hence this observation is in line with our expectations for this target and for IMU-856. We have also carefully addressed hepatic safety in this phase 1 trial and did not see any medically relevant liver events. This slide also shows that there were no Hy's law cases with concurrent increase of liver enzyme and bilirubin. In summary, part B of this trial, using daily oral administration of IMU-856 over 14 days, reached no maximum tolerated dose, and the study was able to reach the planned highest dose of 160 milligram IMU-856. There were no drug-related serious adverse events, and there was no trend for dose-dependent events. There was no trend for post-dose changes in any lab values or any medically relevant changes in ECG or vital signs as compared to placebo. Pharmacokinetic properties seemed well suited for once daily administration and stable and predictable trough levels. In conclusion, daily oral doses of up to 160 milligrams IMU-856 provided a favorable safety and tolerability profile, which also allowed a smooth transition into the ongoing dosing in celiac disease patients. So let's move to our exciting part of this phase 1 trial. We are very excited about testing IMU-856 in celiac disease patients, both because it represents a perfect setting for a mechanism of action like IMU-856, but also as a serious disease with an unaddressed medical need. Celiac disease is an autoimmune disease triggered by the ingestion of gluten-containing foods, but also needs specific HLA receptor constellations in order that deaminated gliadin, an enzymatic product of the TG2 enzyme, is recognized by our own immune system. This immune system response leads not only to increased intestinal permeability, but it also causes very harmful epithelial and mucosal damage, which results in many risk and serious health consequences for these celiac disease patients, including villus atrophy, leading to malabsorption of nutrients. The mechanism of action for IMU-856 contributes to improvement of the intestinal barrier function and the restoration of permeability by triggering regenerative processes of the epithelial lining. In the ongoing part C, we believe we can get a signal on these elements of the mechanism of action of IMU-856. Celiac disease is a serious lifelong disease with currently no pharmaceutical therapies available. Currently, the only available treatment for a patient with celiac disease is a strict gluten-free diet. However, it is known that there is a risk of accidental gluten exposure and inadvertent gluten intake. As represented on the left side, very small amounts of gluten can already lead to renewed disease exacerbation. It is also known from several studies that 1/4 to 1/2 of the patients who follow very strict gluten-free diet have ongoing symptoms and disease activity, most likely due to unavoidable accidental gluten exposure. We believe that these patients are the main target for celiac disease medications. However, there's a spectrum of patients with celiac disease that would benefit from an effective medication, and which would help them to improve their quality of life. I would like to highlight the large number of patients which have a persistent villus atrophy, basically a flattening or disappearance of the hair-like projections in the epithelium of the small intestine, despite long-term gluten-free diet. This villus atrophy can not only cause diarrhea, weight loss, abdominal pain, and fatigue, but also has serious medical consequences such as malnutrition or malabsorption, leading, for example, to iron deficiency anemia, vitamin B12 or folate deficiency anemia, or osteoporosis. This villus atrophy needs to be corrected to address the quality of life for these patients. This slide now summarizes how we're currently performing the evaluation of the safety and tolerability, the pharmacokinetics and the pharmacodynamics of IMU-856 in celiac disease patients over 28 days of daily treatment with IMU-856. The study evaluates both acute, such as interleukin-2, and chronic disease markers, such as villus height to crypt depth ratio, one of the main histological assessments of small bowel architecture. The study includes periods of gluten-free diet, as well as an acceptable low-dose gluten challenge to allow to test the ability of IMU-856 to safeguard against the mechanism of disease exacerbation. We believe that this will be able to highlight the mechanism of action of IMU-856, as well as give insights about the ability of IMU-856 of protecting against harmful effects of accidental gluten exposure for these patients. We expect to present data from this Part C to you in the next year, 2023. I personally would like to highlight again that although we have not fully disclosed the target for IMU-856 yet for competitive reason, it is not a target that focuses on the immune mechanisms of celiac disease, rather a new target that is involved in bowel epithelial regeneration. With this short summary of our ongoing phase 1b trial in celiac disease patients, I would like to hand over to Jessica again to open up the call for the Q&A session.
Great. Thank you, Andreas. Thank you for walking us through the slides. Wonderful data. We will now begin the question and answer session. As a reminder, if you joined the webcast via the Zoom platform, there are two ways to submit your questions. You can either submit in writing via the Q&A tool of the Zoom portal, or if you would like to speak with us, please use the raise hand function of the Zoom portal to queue your question. Our first question today comes from Yasmin Rahimi at Piper Sandler. Yas, please unmute yourself and go ahead.
Good morning, team, and congrats to the data. I hope you can hear me. If you could
yes,
just
good morning.
Okay, great. Thank you. I always worry that you can. A number of questions for you. Maybe the first one is, could you provide some details on what led to the dose selection in your 1C portion? Why do you go with the high dose groups? Did you run any PD biomarkers that gives you some inclination on probability of success into your 1C part of the study? And then lastly, can you enlighten us what type of pharmacokinetic and biomarker data you hope to see at day 28 that gives you a strong inclination of strong proof of concept? And thank you for taking my questions.
Hi, yes, this is Andreas. Thank you for the question, and thank you for participating in our call again. So the dose selection that we did for the Part C, for our part where we investigate celiac disease patients, I have to say that since the safety and tolerability profile was so outstanding in Part A and B, with basically very little, my colleagues always say, I'm usually saying this is the most boring safety profile, but this was really the most boring safety profile. We basically said the Part C gives us the opportunity to understand where we are in terms of dose response. And there's very little that you can do in healthy human subjects to look for biomarkers, for example, in this kind of mechanism of action. to prepare for a patient trial and what happens in patients. So unfortunately, we had thought about this, but there's nothing you could do. However, I think we wanted to make sure that we are in a dose range where we definitely believe that we are in a concentrations that should be therapeutically active. That's why we put also the EC50, EC90 in there, and we also wanted to have 2 doses in there so we can understand, are we already in plateauing? Are we still increasing? So that I think it helps us also for planning of phase 2 at some point, that we have both of these doses available. But in principle, it was more driven by safety that we were able to go as high as possible here for the Part C. And then your second question was about Part C. What kind of data do we expect to basically highlight the mechanism of action, if I understood, and the pharmacodynamic action of IMU-856? So I think we have, and the slide showed all of it, but probably it was too quick. So there is, in celiac disease, it's known that on the first day that you give a gluten challenge, you have a fresh, in quotes, immunological response with interleukin-2 within 4 to 6 hours. And this is the acute response to a gluten challenge. And that's what we're capturing here. And since we are dosing for about 14 days before we have the gluten challenge, so the 856 is on board when we have this acute challenge. So this is the first thing that we'll see. It's the acute challenge setting. And then we have the chronic challenge setting, where you basically, with the gluten challenge, you would you cause a injury to the architecture of the small bowel, and we basically do a duodenal biopsy at the start of the trial and at day 28. So this is something that where we actually see how the gluten challenge, for example, in placebo, has any effect on the architecture of the small bowel, which is known from these gluten challenges that this will be sufficient to see some effect on the architecture, and how IMU-856, which is mechanism to basically promote regenerative changes in the architecture, can prevent this or can dampen basically these changes. So that's the other thing. And of course, we also looking directly at permeability, which is a little bit more difficult to measure. But we have this 2 sugar test where you drink 2 sugars, mannitol and lactulose, and we do this on different time points over the study, and hope to see also that a protection of the increased permeability is happening with 856. These data are probably a little bit more noisy than the IL-2 and the architecture data, but I think it gives you another piece of information about the mechanism of action. So that's how we planned and set up the Part C.
Thank you so much, Andreas. Maybe one last question is, we noticed that there's a higher rate of diarrhea in the active arm versus placebo in the SAD and MAD portion. Is there a reason to believe that, those rates could be further increased when you run it in the 1C portion? What would be the contribution to that, and could it lead to discontinuation? So just some color around those high rates.
So I think, yes, I think that, of course, we have noted this as well, but these has been very mild cases of diarrhea. And with the limited number of patients, I think it's still not clear whether that's really a drug-related event. Even so, I think the investigator, I think here labeled most of these diarrheas as drug-related, which is, I think, understandable for a target in the bowel. We have not seen it in Part A as much, but with the dosing that we have seen in Part B, we had seen some cases of mild diarrhea. I would be cautious and would like to see more data before I consider this to be truly related. we have not seen discontinuation in Part B at all. Also for the diarrhea cases, they're too mild to really have any influence on discontinuation. I think in Part C, you likely will see a few discontinuations, but they have nothing to do with probably the adverse events, but it will have to do that some patients, once they go into the gluten challenge, they don't like this and discontinue. So I think that has been known from other celiac disease trials, but most patients with these dose of gluten that we had selected, I think this is a mild challenge, which is enough to get a response, maybe on architecture and IL-2, but not enough to really interfere with the quality of life for these patients in this trial. So I think so far, and we have now dosed quite a lot of patients already in this Part C, we have seen, I think that the vast majority of these patients have no problem with either the gluten challenge or the dosing, the daily dosing of 856. And so I think I'm very hopeful that this will not be the case.
Got it. Thank you so much, Andreas.
Yeah, thanks, Jas.
Thank you, Jas. Our next question comes from Andreas Agorides at Wedbush. Andreas, please unmute yourself and go ahead.
All right, good morning, and thank you for taking our questions.
Good morning.
Good morning. Yeah, just a couple here. So can you just remind us how big the celiac market opportunity is? And then how are you going about, when you're thinking about patient selection, how are you thinking about the different degrees of severity of these patients and who you're going to put into the trial? We'll start with that. Thanks.
Yeah, so maybe I start with the last question because it's the easiest. We take well-controlled patients in the celiac disease patients only. That means they have to have a history of gluten-free diet that led basically to their celiac disease being well controlled. This has more to do, I think, with being in a phase 1 setting where you have a gluten challenge and you want patients that basically are well controlled when you start the trial. So it's not really maybe the patient population that I highlighted would benefit the best from a drug like IMU-856 in the future. It has more to do with the setting here, how to allow this gluten challenge and really create a opportunity to highlight the mechanism of action here. And now the celiac disease market, I think there is varying degrees of basically the number of patients in different countries. From what we have seen is that in developed countries, there's at least 1% of the patients have celiac disease. I know gluten, of course, now is something that is very fashionable right now. But most of the people that avoid gluten, of course, they don't. Fortunately, have celiac disease. Celiac disease is a much more serious disease, and really has not only quality of life issue, but at really serious medical consequences. So we believe that I would say at least 1%, not likely more, are diagnosed with celiac disease. And like I said, I think there are patients who do well with strict gluten-free diet. They have a well-controlled disease. They have very few symptoms. They don't have villus atrophy. They don't have malnutrition. And they learned how to avoid this accidental gluten exposure. You have to be very careful because I think, unfortunately, very small amount of gluten that can contaminate or cross-contaminate food can lead to disease exacerbation, like I pointed out. And we believe, I think, IMU-856 will target from different studies, we've seen that about 25 to 50% of patients do not basically result in having a well-controlled disease despite gluten-free diet. And so I think it's the 25 to 50% of patients that do not do completely well. They do have these long-term consequences with villus atrophy, and they need a therapy despite gluten-free diet. And here, I think this is the market opportunity that we see in these patients. As much as I can say, I think early at this time point about this market.
Maybe, Andreas, maybe another comment here. This is it's an unmature market. This is a medical need which is just existing, and there's no therapy right now. So you can't project from other treatments right now, and just the patient numbers are really high. And of course, as we show with our trial design already here in the phase 1 trial, we want to really treat the severe portion of patients to really focus on the highest unmet medical need. But that itself, I think, is really a huge market opportunity, which is currently totally untapped.
All right, thank you. I'll jump back in the queue and allow others to ask questions. Thanks.
Thank you.
Thank you, Andreas. Next guest today is Matt Kaplan from Ladenburg-Thalmann. Please unmute yourself and go ahead.
Thanks, Jessica, and good morning, Daniel and Andreas. First, congrats on the clear, PK data. Just wanted to dive in a little bit more to the MOA, I guess, based on 856 mechanism of action. Can you talk a little bit about the potential time course of when you think you should see a restoration of the villus architecture and improvement in the I guess intestinal barrier function as well? How is 28 days of dosing long enough in this patient population with celiac disease to affect a change based on the mechanism of action?
Hi, Matt, this is Andreas. I think this is a very good question. And I think partially we also had to wrestle with because there is not enough known at this point hard data to answer that. However, I think what we have seen in preclinical experiments is that when you look at permeability, IMU-856 is able to really have an effect within hours or a few days. So I think it seems like there doesn't have to be a long treatment period before you have an effect on permeability. And we believe also that the effect of permeability is likely also being driven by regenerative processes in the epithelial wall. Mm-hmm. So it doesn't mean that you can't be sure. You can be sure that the regeneration of maybe a villus atrophy will also happen in a few days. However, I think in this trial, what we're doing is we're taking well-controlled patients who likely don't have villus atrophy, and we dosing them with placebo on 856 for 14 days, and then we do 14 days of gluten challenge. So it's the opposite of regeneration. It's the opposite of, it's more or less, we're protecting against a damage here. Mm-hmm. And we know from other trials, and we have done a lot of careful research here, that the 14 days with this dose of gluten challenge should have a measurable and sizable effect on the architecture. And if there is an effect of 856, we should be able to pick this up. But there is, you always, this is kind of the first trial of 856 in celiac disease patients. So I think usually I expect them a little bit smarter at the end of the trial than at the beginning, to be quite honest.
Okay. No, that's very helpful. And given this is a GI disease, I just wanted to dive in a little bit more to the diarrhea and the abdominal pain that you're seeing initially in the SAD and MAD portion. Can you describe the diarrhea a little bit more in terms of, is it dose dependent? Is it, do you see it as patients are dosed at longer period of time? Is that when it arrives, and is it self-resolving? Can you give us more detail on the diarrhea that you see?
So what I can say for sure is that there is no dose effect. Yes, because we had two 3 doses in the part B, 40, 80, and 160, and the rate was not different. However, I usually caution this a little bit, yes, because you have 6 patients on active and 2 on placebo. Usually you have to be careful to make these statements, but it doesn't seem to dramatically go up or down with those, which usually also means that you have to be careful whether it's a real effect or it's just a statistical phenomenon. But it was all mild. And how it is basically, I'm sorry, I just can't. I'm not really equipped with enough information to say this, other than that the investigator didn't make much out of it because it was a mild diarrhea. But sorry, I don't have a lot more information, Matt, at this point.
And there were no dose interruptions based on.
No, there was no dose interruptions. There were no discontinuations in this trial, in part B also, and definitely this. Even in discussions with our PI in Australia, this has never come up as an issue for him. Yeah, so I think and of course, this was a time when the study was blinded, so he didn't know whether this was placebo or active. But the investigator really wasn't concerned about what he had seen. He was quite pleased with the safety of IMU-856.
Okay, that's really helpful. Thanks for the added details.
No, thanks, Matt.
Thank you, Matt. Again, if you have a question, please use the raise hand function of the Zoom portal. Our next one comes from Govind Singh at H.C. Wainwright. Govind, please unmute yourself and go ahead.
Thanks, Jessica, for the question. Congrats on the data. I guess just piggybacking on all of the other questions, can you share a little bit about the design, if there's any endoscopy being incorporated, and how you're dose titrating these patients? And then I don't know if I know the sensitivity around the target is there. I don't know if you can comment at all related to some of the competitive space in terms of it looks like there's a lot of cytokines being targeted with some of the peers, and maybe even some of the receptors, but usually it looks like it's IV for the most part, maybe 1 or 2 orals. But if you could help us understand maybe the sensitivity as it relates to how you guys are dosing with an oral drug, or the target that you're going after could be differentiating from the space, that would be great. Thank you.
Hi, Govind, Andreas. So maybe starting also with the second is that when we as a company, we believe that if we can use small molecules and dose them orally, I think this would be likely the preferred option for patients in a disease like celiac disease. But I also would like to highlight that there is, we never had the intention of dosing it locally, yes, from the inside of the bowel. So it is an systemic exposure, and the systemic exposure basically brings the IMU-856 to basically the epithelial wall of the bowel from the blood side. That's our feeling how this works. I don't think there's a local action, in case that was your questions as well. The other thing is I know we're a little bit mute on the target, but we know it has nothing to do with the immune system, and we highlighted this several times. And this actually was part of the appeal to us when we licensed in this drug basically a few years ago, was that a lot of the current treatments for gastrointestinal diseases, if you look at many of the gastrointestinal diseases, including, for example, Crohn's disease and so forth, they target always the immunological side, which if you have to give it lifelong, and celiac disease is a lifelong disease, I think will have consequences and will have safety issues. And we really believe that this target, by addressing regeneration of the epithelium and not the immune system, I think it could really be a game changer because it basically takes away the potential, or it might take away the potential for these long-term side effects that for drugs that are really targeting the immune system. Now I talked so much about it that I forgot your first question. So, and I should have written it down. Govind, sorry.
No worries. Basically, we were talking about the villus atrophy in terms of how.
Now I remember. Yes, and whether we do endoscopy. So we do duodenal biopsy twice in this trial. Yes, at baseline at day 28. So duodenal biopsy only works if you have a gastroscopy, basically, and you go in. We do not do an endoscopy in the sense that we do a visual inspection, and it has to do that with these subtle changes in basically villus height to crypt depth that you see. It's very hard to pick them up visually, and you have to do a biopsy and have a experienced histopathologist look at them and make these assessments, and has been done in many other trials. And I think the visual inspection makes no sense here in celiac disease, unless you have extremely severe cases. But the malnutrition and malabsorption happens already with villus atrophy that maybe not visually visible. So we are not doing a visual inspection of the duodenum. We're doing a biopsy, and that's only done twice. And this also has to do that. I think we were very happy that in a phase 1 setting, we were allowed to do 2 biopsies in 28 days in these patients. So that's something that we've worked hard to get into the protocol and be allowed by an ethics committee.
Thank you.
Thanks, Govind.
Thank you, Govind. And we have one more from Lisa Baikiu at Evercore. Lisa, please unmute yourself and go ahead.
Lisa?
Okay, Lisa, we can't hear you.
Still muted.
Okay, maybe we come back to her because I just see one more, which is
No, she's unmuted.
oops, sorry, I was too quick.
No. She's back muted. Lisa is back muted.
Lisa, can you hear us?
Hear me?
Yes.
No,
Hello.
It's so funny. It finally unmuted, and I think I was swearing at my computer. That's a little embarrassing. Anyway, I was just wondering if you could talk a little bit about the preclinical models. Like, how well do they mimic celiac disease, and I guess how confident are you in the observations that you've seen there in terms of, any predictive value for the clinical experience?
Yeah, I think it's not easy, as you know. So does Daniel. So we did a couple of different things in vitro and a little bit of in vivo work. For example, some more typical DSS models, which are typically used for several GI disorders. The TEAE assay, just to test permeability, a typical barrier function test system. So that was all promising, but of course, there is no real celiac disease animal model, which is better here. So we need to trust what we have on that level. I think the TEAE assay was pretty impressive on the barrier function restoration. And also the onset in the DSS model was quite quick, surprisingly quick.
Okay, that's helpful. Thanks. And then in terms of your Part C, can you maybe talk a little bit about, what you're looking to see to feel like you kind of, really might have a drug here? What would you be looking to see to make further investments in celiac disease?
Maybe I start first and then Andreas takes over. So this is a phase 1 trial. Andreas made that point. So we want to see something. And this is a proof of concept we are trying to do here on the one hand, because I think we want to show the drug has that positive impact on restoring barrier function that could be applied clearly elsewhere. There are multiple indications may be interesting. The only challenge we had, and that was the reason why we at the end decided to go into celiac disease, was really that's something where we can, with the challenge design, we can have a much better signal noise ratio and really to come to that point. On the other hand, we think that celiac disease by itself has a huge unmet medical need, and therefore It's a combination of both. So it's just convincing ourselves that the drug works, basically.
And Lisa, maybe from my side, I think I had answered before that we have several measures in there. Interleukin-2 for acute setting. We have the biopsies in there to look at basically villus architecture, and we have the permeability measurements with these 2 sugar tests in there. However, I think in my presentation, I've really focused on villus atrophy as the main risk factor for celiac disease patients. And that really makes a difference for the medical consequences that they have down the road, which are plentiful, and which also, I think, once I got involved in celiac disease and in this program, probably a year and a half ago or so, I think surprised me a little bit, yes, because I think most people underestimate the consequences that celiac disease have if you have villus atrophy or if you have ongoing disease despite gluten-free diet for a long period of time. So I personally think that the villus atrophy and the architecture measurements are probably the most important part of this phase 1 trial. And like Daniel said, I think we had thought about how to implement this and was only able to implement this with the gluten challenge. And gluten challenge is a little bit of a problem to be introduced in the phase 1 trial. We were able to successfully do it. We've seen now in the part C that our participants in part C really, I think, are able to deal with the gluten challenge and in this trial, and that we get these data. And I think this really enables us to get these architectural data for placebo and IMU-856 after the gluten challenge. And I think that, to me, if there's a positive signal there, I think this would be the most wonderful result from this trial.
Okay, great. And what's the timing on data, do you think, from Part C?
2023 is our current guidance.
Yeah, we keep that open. I think you need to convince patients to join such a trial, and therefore let's keep it open for now.
But I think so far we have been very good in terms of attracting patients, and so I think it has good progress in this Part C.
Okay, great. Thank you.
Thank you, Lisa.
All right, we have one more in the queue, which is Mike Krutke from SVB Leerink. No, sorry, SVB Securities, my apologies. Please unmute yourself and go ahead.
Yeah, hi everyone. This is Mike on for Tom. Thanks for taking our questions. I guess just first on safety, did you specify which of the AEs were moderate in the MAD portion, just seen on slide 14, and particularly at the higher 80 and 160 mg doses?
Yeah, I think this is, hi Mike, this is Andreas. We have this all in our filing. I think if you can look there, we have specified which all of the non-mild AEs that we had. There are, I think, 2 or 3 or so that we had, if I remember well. So, but this is all in now publicly available in the file documents.
Perfect. Okay, we'll take a look at that. And then second, I heard you just say timing for data 2023. I guess just would be curious if you have any additional color on just the pace of enrollment that you've seen so far in Part C.
I think I'm not sure that Daniel allows me to say this, but
no. No, I hope you understand that giving guidance here would maybe be the wrong thing. We want to really do it with trial and focus on the quality. And I would not like to put too much pressure on the team here. So good patience and need some time. So as soon as we know how long that takes, we will let you know.
Got it. Okay, totally understood. Thanks for taking my questions.
Thank you, Mike.
Thank you, Mike, so much.
All right, this concludes our question and answer session. I would like to turn the webcast back over to Daniel for a summary and outlook of what's to come for IMU-856 and also for Immunic in general.
Yeah, but first of all, I want to thank everybody for these thoughtful questions and for the good discussion of the day. And of course, we are happy to answer any further questions in one-on-ones after the call if needed. But let me summarize what we have learned today about 856 in healthy volunteers. IMU-856 has shown favorable safety, tolerability, and pharmacokinetic profile in this phase 1 clinical trial with no IMP-related serious adverse events seen and the SAD and the MAD parts. IMU-856 was safe and well tolerated in single and 14-day repeated oral dosing. And we are also very excited about IMU-856 being now tested in patients with celiac disease. And finally, important, and I think that's, I need to repeat that multiple times, that IMU-856 may offer extensive potential beyond celiac disease and other diseases related to the barrier function. But let me also share an outlook on our other programs as well. So we expect multiple value inflection points across Immunic's 3 clinical stage programs. In particular, the next readout is expected to come soon from IMU-935, where initial phase 1b psoriasis data is expected to be available in the next quarter. For our most advanced program, vidofludimus calcium, interim data of the phase 2 CALIPER trial in progressive MS is expected to be available in the second half of 23, and top-line data for the trial is expected at the end of 24. In parallel, the readout of the first of our phase 3 INSURE trials in relapsing MS is targeted for the end of 25. At this point, I would like to close today's webcast and thank you very much for listening.
Thank you, Daniel. Also from my side, thank you for joining Immunic's webcast today. The conference has now concluded. You may now disconnect.